Good afternoon, welcome to today's science lesson. So today is the 12th of February, no it's not, it's the 2nd of February. I'm well ahead of myself. Today is the 2nd of February and our skill today is to use the idea of Earth's rotation to explain day and night and the sun's apparent movement across the sky. Okay, so if you could underline those for me please, neatly with a ruler. Okay, and whilst you're waiting, have a look at this image. Thinking back to our topic lesson yesterday, can you identify what the image is? What can you see? Okay, have a look really closely. Okay, so straight away we can see the arm of the International Space Station. I can't speak today. Space station, okay, this is what it was called the arm. Okay, you may have picked up on some clouds, you may have identified some snow, but I wonder if you picked up on the fact that this is Earth, taken from the International Space Station, and here you can see it's a lot brighter than over here. Why do you think that might be? Okay, so this picture is actually showing day and night from space. Okay, so over here we're going into daytime, so the Earth is rotating towards the sun, and over here it's nighttime. How amazing is that? When I found this image I was so impressed that you can actually see a clear divide between day and night from space. So well done if you did notice that. Okay, let's have a quick recap. True or false? Okay, so we've got some options here and you need to decide whether each one is true or false. Okay, you don't need to write them down, you just need to have a think. If you want to write them down, you can, just on a bit of scrap paper, you don't need to put them in your books. Okay, so the moon goes around the Earth, the sun goes around the Earth is a sphere, the sun is further away from Earth than the moon, the Earth spins on an axis, and the moon is the same size as Earth. Okay, pause the video, have a think, you might want to have a discussion. What you can do, if I were you and I was a bit confused and didn't know, I would be looking back through my book to look at previous weeks, so definitely last week, okay, and possibly the week before. Have a look, in fact all of the weeks we've been doing science and topic. Okay, because most of this information, in fact all of it, is there. Okay, so you've got all of this information of your previous learning. Okay, so please do go back and have a look before you come back to the video for the answers. Okay, so the moon goes around the Earth. Is that true or is it false? Okay, if it goes green, it's true. If it's red, it's false. So that is true, the moon does go around the Earth. Does the sun go around the Earth? Okay, do you remember when we looked at Galileo for our topic? He claimed that the sun was in the centre of the solar system, but before that it was believed that the Earth was in the centre, but it is the sun. So the sun doesn't go around the Earth goes around the sun. So that is false. The Earth is a sphere. Okay, is the Earth a sphere? Okay, it's a 3D circle, so it is. The sun is further away from the Earth than the moon. Okay, that might be a little bit tricky, that one, but that is true. The Earth spins on an axis, probably the easiest one. That is definitely true, you should all know that one without looking back. And the moon is the same size as the Earth, true or false? That one is also false. If you made your top trump cards with the details of the sun, the moon and all the planets, okay, they would have come in handy then, okay, for this. Okay, so it's got all those details on and dimensions and what's biggest and what's not. Okay, so what do we already know about day and night and the Earth? We already know that Earth spins on its axis as it orbits the sun. Okay, it takes 1 day to turn once on its axis, which is 24 hours. Okay. The sun lights up 1/2 of the earth. So we can see here, this is the sun, okay, and it's pointing at the earth here. So the earth is on its way round the sun, okay. This part of the earth is facing, and we learnt that only half of the earth is ever facing the sun, okay. So that means the other half is in a shadow. It's in the darkness, okay, because there's no light getting to it. As the earth spins, okay, it goes from shadow to light to shadow to light because it's spinning on its axis. When it's daytime in the UK, the sun is shining on our part of the earth. Okay, when it's nighttime, we're in the darkness, we're facing away from the sun. Okay, which is how we get day and night. If we're facing away, it's nighttime. If we're facing the sun, it's daytime. Okay, it's daylight. We've got light. The sun's light is reflecting onto the earth. Okay, so why does the sun appear to move across the sky? Does the sun move? Does it move across the sky? Have a think about that. Okay, it certainly looks like it. So during the day, the sun appears to move through the sky. Okay, it does look like it's moving. But remember, this is only happening because the earth is spinning on its axis. In the UK, if we look south and follow the path of the sun in the sky during the day, it looks like this. Okay, so the sun rises in the east. Okay, this is when it gets to the south, and then it rises in the sun sets in the west. I really can't speak today. Okay, so it sun sets in the west, rises in the east, and it looks like it's moving across the sky. It specifically looks like it's moving in this time lapse. Now, obviously time lapses are when it speeds up the time, so it doesn't go as quickly as this. Okay, but we will have a look just to show you the sun moving, or as it seems, its apparent movement. Okay, so here we can see the sun rising. Okay, it's rising from the east. Okay, it's about south there because it's right up centre. And then it goes back down again. You know, it certainly looks like the sun's moving, but just remember that it's the earth rotating which makes the sun seem like it's moving in the sky. Okay, so why does the length of the day change throughout the year? Okay, now you're probably thinking it doesn't change. And you're right, because an Earth day is 24 hours, and it always stays 24 hours, okay? So a full, because that's how long it takes for the Earth to spin on its axis. It's 24 hours. But not every day has 12 hours of daylight and 12 hours of nighttime. Okay, so some days there might be more sunlight or more daylight than there is nighttime, and vice versa, so the opposite. Daytime is shorter in winter than in summer. Let's have a look, see if we can find out why.
Today we're going to look at patterns of day and night to answer the question, why does the length of day change from summer to winter? Let's start with some background knowledge about the Earth. The Earth is separated into two halves by an imaginary line called the equator. The half of Earth that is between the equator and the North Pole is called the Northern Hemisphere, while the half of Earth that is between the equator and the South Pole is called the southern hemisphere. There's also another imaginary line that runs through the Earth from the North Pole to the South Pole, and this is called the Earth's axis. The Earth rotates or spins on this axis, and it makes a full rotation every 24 hours. Now, let's look and see how the Earth and Sun relate to each other. What causes day and night? Well, the half of Earth that is facing the Sun is illuminated by the Sun's light, and in that half, it's daytime. The half that is facing away from the Sun is in darkness, and it is nighttime in that half. Now, in this diagram, the Earth's axis is straight up and down compared to the Sun, but that's not actually what the Earth looks like. If this were true, almost everywhere on Earth would be in the light for half of the day and in dark for half of the day, meaning that they would have equal days and nights all of the time. But the Earth is not straight up and down. It is tilted at an angle of 23.3 degrees. Because of this, the northern hemisphere is pointed towards the Sun at this time of year. In this picture, it's June. What do you notice about the amount of light compared to the amount of darkness now in the northern hemisphere? Well, the northern hemisphere now is getting a lot more sunlight than it did when the Earth was straight up and down. This means that the days will be longer than 12 hours. It's also a lot less darkness in the northern hemisphere, meaning the nights will be shorter than 12 hours. In the northern hemisphere, this is our summertime. The northern hemisphere is not always pointed towards the Sun, though, because the Earth also revolves around the Sun. It takes 1 year or 12 months to complete one full orbit. In this diagram, the Earth only completed half of its orbit, so that would only be 6 months after June, which is December. Now, in December, the northern hemisphere is now pointing away from the Sun. The side closest to the Sun is in daytime, and the side facing away is nighttime. Let's compare the amounts of sunlight and darkness in the northern hemisphere now that it's December. The amount of darkness is now much greater than the amount of sunlight that the northern hemisphere receives. This means that the days will be shorter during December and the nights will be longer. In the northern hemisphere, this is winter time. Now that you know why the days in summertime are longer and the days in wintertime are shorter in the northern hemisphere, you could take this a step farther by researching the following questions. How does day length change in the southern hemisphere? Or, how is day length different during fall and spring? Thank you for watching, and visit www.
Okay, so that was a really interesting video, and it really helped to explain why we have different lengths of days. Okay, so the amount of light in the day. Okay, so that really was helpful, because if the axis was straight and we just rotated on our axis, there'd be 12 hours of daylight, 12 hours of nighttime, but that's not the case. Okay, so the length of the day changes throughout the year because of the Earth's imaginary axis isn't straight up and down. It's tilted around 23, so the video said 23.3, the information I researched was 23.5, so there's probably a little bit of give and take there. As the Earth moves around the Sun during a year, the northern half of the Earth, so that was from the equator up until the North Pole, okay, so that's the northern hemisphere, is tilted towards the Sun in the summer, which made the daytime longer than the nighttime. Okay, and then if we reverse it, in winter, so the Earth tilts away from the Sun, and then the nighttime becomes longer, and the daytimes become shorter. In the spring and autumn, because the tilt is neither towards the sun or away from the sun, but a little bit in between, the day and night times are more similar at these times of the year, rather than summer and winter, when there's a definite shorter and longer day. So when it's night time in the UK, we're in Earth's shadow. Okay, we face away from the sun, and the Earth is blocking the light, which forms a shadow. So can you explain why the size of these shadows change? So if we have a look here, so we've got the sunrise and the sunset. In winter, we can see that the sun is down here, okay, because it's a shorter day, so the sun's lower in the sky. In the summer, it's a lot higher. Why would that make a difference to the shadow? Pause the video, have a think. If you're in the bubble with me, you'll definitely be having a chat about that. But if you're at home, see if you can write some notes about why you think that might be. You might just want a discussion with somebody. Okay, so we can see here that because the sun is lower, this item here, so this column we've got, if you've got a light directly behind an item, okay, the shadow is going to be longer. Whereas if the light is on top of the item, or at a little bit of an angle but higher up, the other side of the item, so the shadow is going to be smaller, okay, because it's not blocking as much light. So the more the light is behind the item, the more it blocks it, okay, making a shadow. So as I've just explained, so the sun appears lower in the sky in winter and sets at around 4 o'clock, whereas in the summer the sun is so much higher in the sky and sets around 8 o'clock, so it means that it's just a shorter shadow. For thousands of years, humans have used shadows created by sundials to tell the time. Have you ever seen a sundial be used? Okay, have you ever used a sundial yourself? Perhaps somebody you know has one in the garden. Okay, so sundials are the oldest known instruments for telling time. Okay, the surface of a sundial has markings for each hour of daylight and, oops daisy, if you look closely, you can see the Roman numerals, which we know XII. We know X is 10, so II is 12. And then we've got 1, 2, 3, and it goes all the way around like a clock. As the sun moves across the sky, okay, this part of the sundial, which is the gnomon it's called, creates a shadow on the markings. Now wherever the shadow is the time. Okay, so let's have a look. Again, this is a time lapse, so it definitely wouldn't be as quick as this. Okay, but I'm just going to show you how the shadow moves to tell the time. If it works. So you can see it's moving, the shadow's moving. So this here isn't moving, it's just a shadow that is, because the sun, or well the earth, is moving. Okay, so when it gets to here, it's around 12 o'clock. And then it starts moving round, and it's really interesting how you can tell the time. Fascinating, really. Okay, so in your books, I would like you to explain why the sun appears to move across the sky and why we have day and night. Now, I don't mind how you do this. This is completely up to you. Okay, so do whatever you feel comfortable with. Okay, you might want to answer some of these questions to help you answer. You might want to write these questions in your books and answer them, or just use them as a prompt to write a paragraph. You might want to draw some pictures with a sentence. Okay, you might want to do some further research, print some information out, perhaps some pictures, and stick them in. I don't mind how you might want to make a poster. Okay, it's completely up to you, as long as you can explain why the sun appears to move across the sky and why we have day and night. So the questions I've chosen to prompt you with your answering is what causes the sun to move across the sky? What is different about the sun's position during summer and winter? How could you tell the time using the sun? And why does it get colder in winter and warmer in summer? Okay, if you're going to draw a picture or choose only to draw one, then this is a really good one to draw because it will help you in explaining why the sun appears to move across the sky. Okay, so it's a really good one to include there. But I don't mind how you do it. The more interesting, the better, really. But as long as I can see your understanding of what you have learnt today. Finally, before we go, I thought it might be quite fun to make your own sundials. Now, obviously we're not really at a great time weather-wise in the year, okay, but you could certainly make one ready for when we have some sunshine, wishful thinking, okay, or at least a dry day. You certainly can't be using a sundial made out of paper when it's raining because it won't last very long. But here's a step-by-step guide. Okay, the scale is a ruler, okay, because it's American, but it's the ruler they're referring to and it says scale. So if you do want to make your own sundial, then you can do it with the paper plate. Okay, however, you don't need to. You can just do it with a bit of circular paper. You can cut out a circle. You could perhaps use a blob of Play-Doh or blue tack and stick a twig in it, okay, to represent the gnomon, which will show you the shadow, okay, or perhaps a pencil. Okay, so it doesn't have to be complicated. It can be as simple as you like, but bear in mind that if it does get wet, it may get ruined. Okay, paper plate's a great idea, but not in the wind because it will just fly away. But we can certainly have a look at making some sundials when everybody returns back to the classroom, hopefully soon, and when the weather's a bit kinder to us and we have some actual sunshine and daylight. Okay, so that is it for today's science. I hope you've enjoyed your learning today. Enjoy the rest of your afternoon and your evening, and I shall see you in the morning for maths. Take care. Bye.